Hello Science Alliance, hello my IGCSEs, here we are again. So I have already taught my free live IGCSE Physics lessons into the internet, and this is lesson 1 where I'm going to try and improve them all. We're starting the whole course again, so welcome if you are watching me live, and if you're watching on catch up, hiya to you too. Right, here's how it works. I'll go quickly because a lot of you will know this, some of you won't. IGCSE Physics, there are two sort of organisations that could write your exam. They are Cambridge and they are Excel. Obviously you can just watch these lessons anyway because they're fun, but if you end up taking one of those exams you'll have to choose in advance which one you take because they need you to learn slightly different things, like only really slightly. So all of these lessons I'm just going to be teaching both what we call the specifications, both all the list of stuff that you need to know, and I'll just tell you when it's just Cambridge or just at Excel. This lesson actually is the information in this lesson is only needed technically if you're doing the Cambridge exam, but it's so useful it's so useful for life, and I've even added some stuff that even Cambridge doesn't need because I just had a lot of fun thinking about measuring things. So, but yeah, if you're revising, don't worry too much about this. Put it on the bottom of your list if you're doing the EdXL exam. Okay, there's no comment stream on this, but if you're watching live, over on my Facebook page at the moment, right at the top of my Facebook page is the post where you can put some comments and I will read those comments out at the end. Okay, right, so let's get going. First of all, I just want to do a little bit of history, because who doesn't love history? These days we use like meters to measure things, or kilometers, but I want to look at, just to get your brains going, some ye oldie timey measurements that we used to have in the olden days and where they came from. The only thing that you might need to know that you might not know for this bit is this is what barley looks like, what grows in fields. So one of these bits here is a barley corn, okay? That's a barley corn. Right, here we go. Wake yourselves up with this. Theatre of history of science. I've got some names of units here, what we use to measure things, or used to, and I've said it's the description. I guess it's the definition. These are real measurements that they had in the olden days, and what that measurement was, the definition. So you've got a furlong, which you might have heard of if you're into horse racing, which these days we'd say that was 200 metres. You've got an acre, which is about 4,000 metres squared. You've got a mile, a fathom, which is 1.8 metres, a yard, which these days we'd say is 91 centimetres, an inch, which we still talk about a lot, which is 2.5 centimetres, and a foot, which is 30 centimetres. And this is their definitions, but they're mixed up, so you've got to match them with what you think. 3 barleycorns end to end, a man's foot, the distance that 8 oxen could pull without a rest, genuinely how they used to measure distance in the days gone by, a man's outstretched arms, the amount of land 8 oxen could pull in one day, if they had little rests, 1,000 double human steps, and the distance from King Henry I's nose to his thumb. Go on. And then I've put, if you find that too easy or you want to get your IGCSE brain on, why isn't any of that a great way to measure things? Like, you can get away with it if you're measuring cloth, but if you work at like the Large Hadron Collider, you're going to need a better method. Why? How you doing? I must say I'm doing a great job of being quiet. This is quite unusual for me. I'll give you like, I don't know, 10 more seconds. All right, should we go through it? It's just a bit of fun, this, just to get our brains working. Oh, such a thing. The history of science is so interesting. So a furlong, again, which we still use today, was traditionally the distance that 8 oxen could pull before they had to take a bit of a rest. So I guess the clue was in the units, the metres or the metre squared. You're okay with this, right? I assume. that if you're measuring a distance, we'll talk about this more later, if you're measuring a distance, it would just be measured in meters. If you're measuring an area, like, I don't know, like that, the area of this square would be the distance of one of the sides and the distance of the other side, and you times them together. And when you're timesing numbers together, you also times the units together. So if this square is 2 meters long and 2 meters wide, then you get an answer of 4, but also you times the meters together. So the area would be 4 meters squared. Right? We'll talk more about that. I'll drip the maths in gently as we go along. So yeah, the acre, which is an area, that is the amount of land 8 oxen could pull in one day. Still talk about acres a lot. A mile, I think it was the Romans that made this up, wasn't it? It was 1,000 double human steps, and the Romans used to have like specific humans who were paid to do it. A fathom is traditionally a man's outstretched arms. So you've got that beautiful line in The Tempest. You ever read The Tempest by William Shakespeare? This prince ends up on an island, and the island spirits sing to him, "Full fathom 5, thy father lies." Full fathom 5, thy father lies. Much better than saying is at the bottom of the sea. So if you stretch your hands out, if you are but a woman like me, then it would have been 5 of those, and even if you're a child, you know, it would be 5 of a grown man like doing that under the sea. That's how far his father was lying under the sea. Yard was the distance from King Henry I's nose to his thumb. He's the one that formalised the length of a yard. An inch is 3 barleycorns end to end, and a foot is, a man's foot. And if you were thinking about why there's not a great way to measure things, hopefully you got the fact that obviously not all men have the same size feet, not all men have the same length arms, so measuring at different times using different people would give you very different results. So, you know, you'd be more likely to go and buy your cloth from the man with the long arms, I suppose, because you get more cloth for your money. Probably the King Henry I one is actually sort of the most consistent, isn't it? Because at least that's just one person you're measuring it against. Right, so we're actually going to go a little bit into A-level physics here before we bring it back, because I just think this is such a useful thing to know as we go along. Pretty much the whole world these days has agreed to use 7 standard units for measuring things. They're called SI units because SI stands for Système International because it's French. We're only going to look at 5 of them during IGCSE. The second, which measures time, metre, which measures distance, kilogram, which measures mass, more of that later, amp, which we'll talk about, which measures electric current, and the Kelvin, which measures temperature. So all the other units that we're going to talk about on this course, they're all defined by these ones. So like we can talk about centimetres, but technically the definition of a centimetre is that it's 1/100th of a metre. Okay, so like for example, just to get really weird and complicated here, we'll talk about joules later that are used to measure energy. And you'll go, oh, Lara, a joule isn't on the SI units. Yeah, another way of saying joule, which measures energy, is a kilogram metre squared per second squared. So even the joule is defined using just one of the combination of these 5 units. You do not need to know this for GCSE. You would need to know this for A-level, but I just think it's so useful, especially when we come to do maths to do with metres and kilograms. You can really check your work in if you know that. So these days, we don't, because obviously barleycorns are different lengths, aren't they? These days, to get a really reliable measurement, the ruler factory or whatever uses a distance or a mass that is defined by nature. So 1 metre is defined now as the length of the path travelled by light in a vacuum in 299,792,458th of a second. Okay, because that's not going to change. Like you have to say it's in a vacuum because it travels at a different speed through air. But yeah, the distance that light can travel in that much time, that is 1 metre. The last one of these to go was the kilogram. Even when I was doing my physics degree, how we knew what a kilogram was there was an actual kilogram made of mainly platinum kept in Paris under 2 bell jars to protect it, and that was the definition of a kilogram. The problem with that is everything, even if it's very, very, very unreactive, does react over time. So what was happening was the particles of the kilogram were reacting with the air around it, and very, very, very slowly it was getting ever so slightly lighter. So now the kilogram has got a definition defined by something to do with nature. Right, let's crack on with what you actually need for IGCSE Physics. If you're doing the Cambridge spec, they want you to know how to measure things with a ruler. Oh, it sounds easy, doesn't it? Let's see how complicated we can make it. I've done loads of talking. Come on, you do some work. Some foolish IGCSE students have tried to measure things with a ruler, thinking it would be easy. So I've got 5 images here of these poor students who are trying to measure a piece of string with a ruler. Can you look at these pictures without changing anything? Which pieces of string can't you measure the lengths of accurately in these pictures, and why? So all these are centimetres, I haven't bothered to say, but this is a bit of a ruler and you're looking at the numbers are in centimetres. So A is a very neatly cut off bit of string, which is one end's lined up with the 0 of the ruler and the other is lined up with the 2 of the ruler. Can you measure that piece of string accurately or not? And if not, why not? B, you've got another nicely neat cut off bit of string, which starts just before the 0 and ends like 2 small notches after the 2. C, you've got a straight, neatly cut off bit of string which starts at 0 and ends at 1 notch after 2, but the 1 on the ruler has been scratched off. That's not really very clearly visible. D, you've got one, that's supposed to start at 0, okay? You've got a straight bit of string starting at 0, but the other end of the string is very frayed. So you've got a short bit which is like 2 and 7 small notches long, and you've got a long bit which is 3 centimetres long. Can you measure that accurately? And E, that is supposed to start at 0 as well, sorry. You've got a straightly cut off bit of string that starts at 0 and ends at 2, but it's slightly curved, so it's curving up and then it's coming down to the 2. Which one of those can you measure accurately and which ones can't you measure accurately? And the ones that you can't measure accurately, why not? And I've tried to kind of trick you. I always try and make it a little bit tricksy, like not totally obvious. So the people who really quickly and confidently start giving me answers, I want them to be wrong, basically. Because, I don't know, teachers are evil. How are you getting on? Should we go through it? So, A, can you measure that piece of string accurately? I have said, yeah, I reckon you can. Apologies if you're, sorry, if you feel like I've gone too fast and you didn't get an answer, then if you go to my website next time, don't go this time because it's all on the board, but if you go to my website, you can get the worksheet for free, which has this printed off, if you'd rather like pause and go more slowly and stuff. So yeah, I would just say that's 2 centimetres, except I could do something else there, right? Because this ruler isn't just measuring in centimetres, so the long lines on this ruler are marking out half a centimetre. You okay with that? We've got, it starts at 0, the next long line is half a centimetre, because then it's 1 centimetre, 1.5 centimetres, 2 centimetres, but actually this ruler is showing tenths of a centimetre as well, millimetres. So if I just write 2 centimetres there, the person reading this later doesn't know how precise my equipment was. I can see that it's not 1.9 and I can see it's not 2.1. So to tell them that, I would write this as 2.0 centimetres because I can be that precise. I can go to the tenths of a centimetre. The next one, it doesn't start at 0, can it? So you can't, you just can't. You'd have to be estimating there because, yeah, you would just be able to say that it was, well, you just have to estimate. You can't do that because you've got to line it up with 0. C, yeah, I've said that that's totally fine. It's a little bit scratched off the number 1, but it doesn't make a difference to your reading, does it? It's still quite clear what the equipment is saying. And again, I would write that as 2.1 centimetres because if it starts at 0, which it does, I can see that it's closest to the 1 millimetre after the 2 centimetres. So that would be 2.1 centimetres for me. A, B, C, D. Oh yeah, D was the one I think where I thought I might trick you, because this is the one where it was slightly frayed. So I thought a lot of you were going to say, no, you can't measure that accurately. I think you can, but you'd have to be consistent, right? And if you were doing this as part of an experiment and you were writing a method explaining what you'd done, you'd have to tell the person who was coming to try and do your experiment after you what you'd said. Apologies, it doesn't really start at 0, does it? But it was supposed to start at 0. So you could have said it was 2.7 centimetres, or you could say it was 3.0 centimetres, but you just have to make sure that you did the same thing every time, because otherwise if you measure the longest bit one time and the shortest bit the other time, obviously that is going to give you very inaccurate, unfair results. But as long as you write down, I'm going to make sure I measure the longest bit of string every time, I think that'll be all right. E, yeah, you can't, because it's curved, isn't it? So you can't possibly measure that. You'd have to straighten it out, and it would be longer than what is showing. Okay, what about then? People think physics is boring. Come on, get a load of this question, guys. What length would you say this piece of string is? Oh, what length is that piece of string, kids? What do you think? So it starts at 0, but then, it's not 2 centimetres, is it? But, because it's a bit longer, but it's not 2.1 centimetres, because it's a bit shorter. What are you going to say? So what I'm getting at here is you've got to be very careful with like how many decimal places you give your answer to. You can say that this is over 2.0 and you can say that it's under 2.1. So it would be okay to say that that was 2.05, for example. You couldn't say, I think it's 2.404786, because you just can't be that precise, because the person who made this ruler didn't design it for being that precise. But you can go to the half, so you could say 2.05 and that would be all right. This is why I think sort of arguably digital clocks are preferable for measuring time, because it's very, very easy to read the number, isn't it? Whereas there's a little bit more give or take on an analog clock. And this is why when I'm making bread, which I do, we've been discussing this in the fungus lessons earlier. No one eats it in my family, but I still make it. When I'm weighing out my flour to make my bread, I use these scales here, which just have notches for every 25 grams is a notch. That's fine, because I use about 500 grams of flour. So like give or take a few grams, it doesn't really matter. But when I'm weighing out my yeast, I only need 7 grams of yeast. So obviously, if I tried to measure 7 grams out using this, it would be impossible, right? Because it just hasn't been designed for that. I can only really see what maybe I could go for a halfway and say 12. But with this scale, it's got more decimal places. So look at that! Look what an experienced bread maker I am! Sorry, tangent. Yeah, it's got more decimal places, so I can measure that out more precisely. Right, Cambridge need you to know this. You can also use a ruler to measure 3D shapes. We're just sort of going to skip this bit. You know that, don't you? That we've talked about that. You measure that length of a square and then the width of a square or whatever, and you times them together, and then you times them by the depth of the square. You get the volume. So that would be like if it was 2 meters times 2 meters times 2 meters, then the volume of that square would be 2 times 2 times 2, which is 8. Volume of the square, sorry, mathematicians watching, the volume of the cube would be 8, but you also times the meters together. So a meter times a meter times a meter is a meter cubed, okay? So that's why the answer would be 8 meters cubed. Right, let's do something. Can you please get a glass of water and a pen, and we'll do a practical. So yeah, what a lovely gentle introduction. The Cambridge specification also needs you to know that measuring cylinders are used to measure volume. You might well have a measuring jug at home. This is what they look like in the science lab. Yeah, we're just going to use some water. So I am going to put some water into my glass of water. Don't do it right up to the top, but I don't know, just normal like glass of water length. What I would like you to do, please, depth, is can you please get a pen, as long as it's okay, don't use like your poshest glass. Can you get a pen? And first of all, you need to make sure that the water has stopped moving, right? To make it a fair test. What I want us to do is mark on the side of the glass where the water level is, okay? we're just going to mark on the side of the glass where the water level is. So number one, obviously, wait until it's stopped moving or it'll be slopping up and down and that won't be very accurate. But first of all, when you do it, can you do it looking down on it as steeply as possible? It's actually very difficult to do. I can't really do it through my camera, so I'm going to just look to the side. But look above it. You need to be able to make sure that you can actually see the water line, but look at it from really high up and then put a line where it looks to you like the surface of the water is. Okay, that's that. You done that? So I've drawn a line where I think the surface of the water is on my glass of water, looking at it from really high up. And then bring the glass of water to the edge of the table if you can, and go, or like yeast on the table from earlier today. And do the opposite, look up as high as you can. Look from as low down as you can. So yeah, it helps if you can put it on the side of a table and then sit down in an awkward position like I'm doing now, and then mark where you think the water level is again from looking down, and you can see hopefully what I'm getting at here. So I'm leaning right down. It might look slightly different. It might look like I'm getting it wrong because I'm at a different angle to you, if you see what I mean, because I'm not looking through my camera. Right, there we go. Phew. And then come back up to look at it on eye level, and what do you see? I'm actually, because it's important to stay hydrated and also because you'll see it better, I'm going to empty some of this water out now. So I've got 2 pen marks on my glass, and they were both made when the water level was at exactly the same height. There we go. So what do you notice? And you could do this a few times if you wanted to prove to yourself that that was the case. The pen mark when you were looking down should be higher. In this case, it's quite a lot higher than the pen mark when you were looking up. So we've managed to make using a measuring cylinder quite complicated as well. What you have demonstrated there is something called parallax error. This is why when you're measuring something, so you might have noticed it if you ever read something off a thermometer, you know how the glass is quite thick, this happens. If you're looking down on it, you will get a reading that is higher than the actual result, what we call the true value. And if you're too low, then you'll get a result that is lower than the true value. This is why it's very important to make sure that your eyes are level with the level of the thing that you're measuring. And the other thing, I couldn't work out how, actually I maybe could have done, I couldn't work out a way to show this using household objects. But if you've got something that is very thin and see-through and you put, like a test tube, and you put some water in it, you will find that the water curves because water is sort of sticky. So you get this thing called a meniscus, which is the water curving. And the rule is always measure from the bottom of the meniscus. You're going to forget that word. I'm going to ask you a question about it at the end of this lesson. That's fine. But it's the meniscus, is that curved bit of water. And yeah, you read from the bottom. And all scientists everywhere do that to make sure that they always get the same result. Read from the bottom of the meniscus. Okay, let's do another practical. Let's get a little piece of cotton and some scissors and some blue tack. And we're going to make a little pendulum and think about how you measure the duration. I shouldn't say length really, because we're measuring time. It's a bit confusing. So yeah, get just a little bit of cotton. I mean, you don't really need the scissors to be honest. Get a blob of blue tack. Stick the blob of blue tack onto the piece of cotton and you have made yourself a pendulum. Scientists can be very pretentious. It's just a blob on a string, like, you know, a grandfather clock, the thing swinging underneath. That's a pendulum. So I think we do get to learn about pendulums later because I love the science of pendulums. It's really surprising and we get to talk about Galileo. But anyway, for now, all you need to know is that a pendulum is a blob on a string. And, oh God, what is sore nose? Sorry. Thought that was face paint from my jellyfish Lego show. Yeah, a pendulum is a bit of stuff on a string. And I'm saying swing because we haven't got there yet. What we're actually talking about is its oscillation. So what a pendulum does is it oscillates to and fro. It just sort of means swinging. And the other weird thing about a pendulum swing is you would think that one swing would be the distance from well, you would think that if you measure one swing, you're measuring the time it takes to get from one side to the other side. But no, a pendulum's swing is the time it takes to get from one side to the other side and then back again, right? That's one swing. From there, all the way over to there, and then back again. So I want you to imagine, we're not actually going to do it, but I want you to imagine that you've got a friend who's got a stopwatch, say, quite an accurate stopwatch if you like. You're going to hold your pendulum up, you're going to say go, they're going to press the stopwatch. How are you going to make sure that you accurately measure how long it takes, the amount of time it takes your pendulum to go from starting position to the far side and then back again, one swing? How are you going to do that? Imagine you're shouting, go, stop. What are you going to do? Is that what you're going to do? Are you going to shout, go, stop? Is that what you're going to do? Go, stop. Some of you might be saying things like, record it and then play it back in slow motion. That's very clever. Don't say that. Think about if you wanted to measure it, if we don't have computers. What would you do? If you're thinking, no, I don't think that would be a very good and accurate way, I don't think that would get me close to the true value to go, stop, then yes, you are correct. So either of these stop clocks that we've looked at would be all right, wouldn't they? And not if it was the Olympics, but they'd be okay for timing someone using a 100-metre race. But there is an issue with timing the pendulum swing that you might have noticed. The clue is, it's not a problem to do with the equipment. It could be it could be the most accurate stopwatch in the whole universe. And there were, oops, sorry, that was my phone telling me that my battery was getting low. It's fine, it'll get us through. Yeah, there's a problem using these there's a problem with that start-stop method for measuring the length of this pendulum swing. And you could have the most accurate, precise measuring stopwatch in the universe, and it would still be a problem. It's not an equipment issue. It's your reaction time, isn't it? So the solution is time more than one swing and then take an average. So 10 swings, we often say. So if you imagine that it takes, say, like 0.25 seconds after you've shouted, go, for your friend to press the stopwatch, and then again for them to stop the stopwatch. If you're measuring a very small, a very shortly timed, if you're measuring a small thing, then that reaction time is going to have a huge effect on the like certainty of your measurement, how sure you can be that you've got the true value. So what you would do is you would say go, and you would time 1, 2, 3, 4 to 10, and then they would stop, and then their reaction time gets sort of shared out over more measurements, if you see what I mean, because it's one reaction time per 10 swings. So you take how long it takes for it to swing 10 times and you divide it by 10, and that gives you a better, more certain result for the length of one swing. It's the same with length, length. Like if you wanted to measure the thickness of one A4 piece of paper, you wouldn't try and measure the thickness of one A4 piece of paper. You might put 100 A4 pieces together and then measure the thickness of that, and then divide your answer by 100, yeah? So if you could be bothered to time 1,000 pendulum swings and then divide that by 1,000, you'd have an even more accurate answer. We may talk about the difference between accuracy and precision later. That's another A-level thing. All right, so teeny weeny little bit of very gentle maths for you here. I don't know how well I've written this question. You got 2 students, right? And they're both doing what you just did. They start some pendulum swinging and they use stopwatches to time 10 swings. So you've got student A and student B. So they've both done this. They've both timed 10 swings with their stopwatches. The images show their stopwatches before they press start and after they press stop. So can you work out the duration of each pendulum swing? Okay, so student A has timed 10 swings. Before they press start, their stopwatch said 0.00, and then when they press stop, it said 0.30, so like 30 seconds. So if that's the length of 10 swings, how long is one pendulum swing? And student B, their stopwatch said 5 seconds when they press start, and then when they press stop, it said 55 seconds. So what is the length of one swing of their pendulum? For some of you, this is going to be very easy. For some of you, you're just going to be in a bit of a panic because IGCSE Physics has got a reputation for being very difficult. So we're starting gently. The maths will get harder, but we'll just kind of dribble it out and you'll be fine. We're not on a timer, are we? You can always go away and search stuff yourself if you're not sure. How are you getting on? We'll go through the answer, because if you don't know it, you probably need the answer, and then you'll understand. And if you do know it, you probably got it by now. Don't forget, if you're watching live, there's a post on my Facebook page now which says, comment here if you're watching live. Right, here we go then. So student A, what would you do? Well, it took exactly 30 seconds for their pendulum to do 10 swings. So you share out those 30 seconds among the 10 swings and you've got how long it took to do one swing. So 30 seconds for 10 swings, 30 seconds shared out among the 10 swings divided by 10 is 3 seconds for one swing. And the other one, well, you've got to take 5 seconds off because it started at 5 seconds, so you've got to disregard that. Take 5 seconds off the final time. So you end up with saying it's 50 seconds for 10 swings, and again, you share 50 seconds out among 10 swings, and you get an answer of 5 seconds for one swing. And there you go. That wasn't too bad, was it? All right, so I've got, I can't actually show you past paper questions because that would be bad for copyright reasons, but on my website, after this lesson, not like straight after this lesson, but there is a PDF of like what I call further reading and homework. So after this lesson, at some point on my website, I'll add to the PDF with some past paper questions that I think you should be able to do after you've done this lesson, and then some further reading, like maybe the good websites that I found useful for planning the lesson. I'll give you those as well. I don't really recommend any textbooks. To be honest, I don't pay for anything that I use to plan these. I mean, I am trained to teach IGCSE Physics and A-level Physics, so I've got a head start on you probably. But yeah, I don't pay for any textbooks. I find some of them quite dry. I think there's a lot of really good free resources out there. So don't feel the need to do that. Yeah. Right, okay, well, let's do this question and then I'll go to my Facebook page and chat to some of you and give you my ad as well to tell you how these lessons are completely free, even though this is my job. Questions. A student measures the length of their pet worm as shown below. They decide it is 9 centimetres long. Suggest 3 things they could do to make their measurement more accurate without getting a new ruler. On Facebook, when I did this lesson yesterday with comments, people got 2 of them straight away. I don't think anyone got the third one. So you've got a wiggly worm here, which is starting at about 1.5 centimetres on this ruler and ends at 9. So this person has decided that it's 9 centimetres long. How are you going to improve that? And question number 2, a student, and then I put, sorry, what a boring start to a question. Why is it only ever students doing these things? Anyway, a student measures the volume of a liquid from a test tube as shown. Test tube of water, slightly curved surface of the water, eyes far above the test tube. Can you name 2 things they should do to make their measurement as accurate as possible? I told you I was going to test you on it and I said, oh, you won't remember the word. Should we go through it? You think you found this third one on the worm question? Let's have a look. anyway, this isn't the exam, this is about learning. So if you don't have a clue and then I tell you, then you've learned, haven't you? So one of the things you could do is to gently straighten the worm. Someone said on Facebook yesterday, just get a bit of string, put it along the worm and then measure the string. I was like, oh yeah, that's much kinder. But anyway, gently straighten the worm would be one thing to do. Use the millimeters and not the centimeters. That will give you a more precise reading, won't it? Because here you can't really say whether that's like 8.9 or 9 or whatever. And position the worm at the 0 line on the ruler. Well done if you got that. I think if this was a GCSE question, actually I would probably position the end of the worm at the 0 line on the ruler, just to be really, really sure that the examiner knew what I was talking about, so that I didn't mean just like splat the middle of the worm over the 0 line. Should have said position the end of the worm at the 0 line. Anyway. And question number 2. What could this student do to make sure their measurement is as accurate as possible? Read from the bottom of the meniscus. Did you remember that? So that curved surface of the water is the meniscus, so read from the bottom of it. And the other thing is have their eyes level with the level of the liquid. And if they ask for 3, another thing you could do, as I've put, is maybe like make sure the liquid isn't moving as well if they've just carried it over to the table. But I think the first 2 would be a good answer. Right, you lot. That is the end of my first IGCSE Physics lesson of this completely new block on YouTube. So thank you extremely very much for joining me. I'm going to go over to my Facebook page now and have a look at if you've left me any comments or excellent questions. How this works, I'll do my ad. How I can do this for free, even though this is literally my job. And then my husband lost his job. So this is now the only way that my entire family makes money in my house. It's amazing. Lessons are free. Printouts are free, PDF of past paper questions is free, all ages lesson that I teach, which we're doing in my college at the moment, free, printouts free, Lego sort out, it's all free. And how it works is I just say, if you're using this as a resource and you're thinking that this is useful and worth £5 a month, then you can pay me £5 a month. And people are. It's so weird. I'm like, who would actually do that if you don't have to do it? But people are doing it. So yeah, if you go to my About section, actually, because you're on YouTube now, if you go to my About section, there is a web link to this website called Coffee. And if you click that, you can sign up to send me £5 a month. I do send people nice things to say thank you. I will send you some diffraction glasses, which make you see rainbows, and a description of how they work, which won't be not useful if you're doing IGCSE Physics. And I send you Theatre of Science magazine. I'm laughing because it is, I think, the best and the least reliable science magazine in the universe. This one is on acids, so if you sign up with £5 a month, you get this one. It's got, I mean, it looks a bit kiddie, but to be honest, I don't know any of the information in Theatre of Science magazine before I read it. So it's kind of like all the stuff I do. It's supposed to appeal to like adults and kids, really. It's got Choose Your Own Adventure, where your knowledge of acids will decide whether you get stuck in Shakespeare's day or not. It's got a which acidic object to you quiz. It's got why acidic things are not good for your teeth. It's got a beautiful comic that my husband illustrates for me about acid rain and how acid rain is formed and whether it's a problem or not. It's got some wonderful activity ideas, and it comes with some sweets you can eat that are sour to ponder why why acidic things taste sour while you're reading about them, and some litmus papers as well, so you can experiment with some stuff around your house. And if you sign up with £6 a month, I will throw in a past issue, which is the Mould magazine, which comes with a free, gasp, biodegradable, home compostable plastic bag, so that you can grow some mould and study it and then compost it. And you can sign up with a lesser tier if you're thinking, I just want to give you money for these IGCSE lessons, I don't really need your sporadic magazine. Okay, right, I am going over to my Facebook page to see if anyone has said hello. I just need to refresh. That's my holding music. Oh, here we go. Ruben and Kobe are here. Hey, for the first time. Yeah, dudes. Hello, Ruben and Kobe. I'm just like optimistically assuming that they're still here. Hi, Ruben and Kobe. If you're still here, brilliant. Arthur is here. I'm doing my excited voice. I've still got this thing. It came on last year where I just lost my voice for ages. And it still happens if I get too excited or talk too much or talk too high, then my voice goes. So, Arthur, I am very excited that you are trying IGCSE Physics for the first time. I hope you enjoyed it. He asks if you have relocated to your new loft space. Arthur, yes and no. My children have located to the loft space. So more rooms are free in the house. So that room is now this room where I am. So yeah, you're right. Arthur was watching last year when I was having my loft conversion done and was working from the corner of my kitchen. It's very unpractical. So yeah, I am. Good, eh? Look, I've got like fancy shelves and that. I'm not going to show you the rest of it. I'll show you it later. You love the science magazine. Oh, Ruben and Kobe, thank you. That was really kind of you. Oh, Gus. Gus. Hello, Gus. Trying to put on the voice that holds my, keeps my voice. Hello, Amelia and Kitty. Except this time it's the official Amelia account. Ho ho! Got your own account. Nice. Welcome to the dark side. Hope you've had a great summer. Thank you. I did have a great summer. All right, Tyler. Hello, Tyler. Oh, Tyler, I was thinking about you this morning because, yeah, when I was setting all this up, right, Tyler made me the most fantastic, oh my God, this is so cute, Wormy. And the reason Wormy isn't here is just testament to how cute Wormy is because my daughter ran off with Wormy. So I can't, she'll be somewhere. She'll be like under a bed or a cushion. Yeah, Tyler, so you just have to keep coming, mate, because like, oh, you were coming anyway. I don't need to draw you in, but yeah, sorry. It's doing very well. It's very loved. Are you making more? Have you making more? Tyler and I are going to get business. Well, he's making them. I'm just like going, make me some, so that I can make loads of money and sell wormies to everybody. Hello, Violet. Violet came. Awesome. Right, I'm just going to refresh to see if there's any more comments. Because I know it's really annoying when you just find out that I chat to you in the comments on Facebook and then I go away. It doesn't look like there's any more comments. I think we're all right. Let's go to newest. Oh, you are still here. Brilliant. Ruben and Kobe are still here. Oh, but are they still here? They were here. But I think they are still here. Hello. Thank you. Arthur, did you have another question? Oh, yeah. That's a good question. Why do we use Celsius here and in America they use Fahrenheit? Do you know, I've done so much research into the history of temperature because I find it really interesting. I can't remember. We will do a lesson on temperature when hopefully, like, I'll read it again and then do it in the lesson and you'll think, wow, Lara knows all about temperature, and then it'll just fall out of my head again. Yeah, I don't know. I mean, they're both, neither of them make a lot of sense, but Celsius makes slightly more sense than Fahrenheit. Celsius, you know, the scale of temperature for Celsius is what temperature water freezes at and water boils at, whereas Fahrenheit, it's like salted water or something. I don't know. The reason why American spellings are different, you know how like in English, British English, colour is spelt C-O-L-O-U-R, but in America they cut out the U. It's because an American, when Britain used to own America and America was starting to go, we don't want to be owned by you, we want to be our own country. One of the Americans went, and we want new spellings too. I don't want any of these spellings. They're silly. We should simplify them. And then did. And they took off, which is why the spellings are different. But I don't know if Fahrenheit was Americans going, we don't want to be anything like you anymore. We're going to measure the temperature that brine freezes at. I don't know. You'll have to look it up for me to tell me. Right, I'm going to go. Thank you so much for joining me. Thank you so much for everyone who has signed up. Obviously it makes a massive difference to my life because if you weren't signing up to support me, I'd have to work in a school. So yeah, hopefully I will see you next week when we will be learning about, I think it's distance time graphs next week. Yeah, see you then. And look out, I'll put a post on Facebook when I have put up my homework PDF. But yes, until then,